The term physical drive storage device refers to the hard disk drive itself. This is a physical device that contains platters or solid. So this is the solid state that holds data. So the term logical device volume partitions refers to the formatting of a physical device that can contain one or more logical worms, the device, and partitions. It's a common misconception that term C drive refers to the physical drive actually. So when in actuality it refers to a logical partition on this physical device. So several components make up the interior of the hard drive as shown in this diagram. If you were open to the case, you will find that the hard drive comprised of one or more platters. There could be one or more platters stacked together with a spindle in the center. The platters, which are made of metal alloy or glass. And coated um, with a magnetic substance in which the heads magnetically encode information um, into the platters. Let me show you some hard disk here. This is the inside of hard disk. As you can see here, this is a ribbon cable, actuator, actuator axis here. This is the actuator of the hard disk, and with this actuator arm, we can read and write our data into these platters. This is the spindle, and this is the platter that actually holds the data. So the spindles of the hard disk cause the platters to spin increases the efficiency of accessing the data encoded on the platters. To read or write data to the platters, the heads are positioned less than 0.1 microns from the surface of the platters. Additionally, the actuator control heads here um, it swing across the platters, placing the head into the correct positions to read write the data. The storage devices are manufactured with tight tolerances and can be damaged by movement or by mechanical shock. So a drive can have different interfaces. For example, you may run into some of the following in this list here. So a hard drive can have different interfaces, as I said. For example, this list here. So small computer system interfaces, SCCI. This is an older standard that is typically seen in the corporate environment, limited to 16 chain devices and will have a terminator at the end of the chain. And we have here integrated drive electronics IDE. This is just older standard, but may still be in found older computer systems. This is a serial advanced technology attachments SATA here. This is the current standard found in many user and commercial environments. And lastly, we have serial attached SCCI, the AS. So this is the current standard. It's typically found in commercial environments. Now let's get dive into the state drives, SSDs. So SSDs drive storage device that contained no moving parts. Is that they are made of memory chips. As we discussed earlier, a traditional hard drive has several moving parts in which to read write data to the spinning of platters. With the SSD storage device, all of the data is stored in memory chips. So is allowing for um, there is a SSD's benefit over hard disk drives. So SSD is a lot less weight. SSD has increased reliability. It has improved data access speed and reduced power consumption. For an SSD to function reliably, there are several options controlled by the firmware of the device. We know these functions are wear leveling. So this spreads the writes across the device chips so that it uses the chips at the same rate. This will be trim here. The trim will wipe the unallocated space of the device. And lastly, we have garbage collection. As the firmware scans the memory modules, it may identify pages within the data blocks that have been deleted. The firmware will move the allocated pages to a new block and will wipe the data blocks so that it can reuse the blocks. So the firmware can only delete data in blocks. In real world effect on forensics is that we can no longer recover data that is or was in unallocated space, since these operations are conducted at the firmware layer. As soon as we give power to the device, these operations start automatically. Currently, there is no way to stop firmware from doing the functions mentioned in this lecture. So the drive geometry details how data is stored on the device. So the drive geometry defines the number of heads, the number of tracks, the cylinders, and the sectors per track. So the manufacturer performs what it refers to as low-level format, which creates a basic structure of the disk by defining the sectors and tracks. A track is a circular path of the surface to the platter, as indicated here. So this is the red circle here, as you can see here. It's a single track. So this is a single track, and each side of the platter will have its own set of tracks. They then subdivide the track into sectors. As you can see, we have sectors here, 1, 2, 3, 4. So a sector B here, this is the sector B, is a small storage unit on the device. So originally, a sector used to 112 bytes in size. So actually, let me write it down for you here. Sector is uh, uh, most of the storage device, right? So originally, so here our sector is 520 bytes in size. However, um, the newer generation disks can be formatted like 4096 bytes in size. New generation disks are being formatted with a sector size of 4096 bytes. The platters here have an addressing scheme, so they can locate the data. So originally, cylinder head sector was used here. So here cylinder refers to the vertical axis of the same sectors on our platters here. Um, Heat refers to the read-write heads. Each platter has two heads, and in this case, the sector refers to the number. Sector refers to the number of. Sector refers to the actually number of sectors per track. So sector refers to the number per track. This addressing scheme worked for large capacity hard drives. However, as the storage capacity increased, there is There is this CHS scheme called not scale here. So logical block addressing LBA here was created. Actually, let's okay. So we have discussed the physical components of the device. We will now dive deeper and examine some of the internal aspects. So actually, in this after this lecture, you will wait and give practices about this lecture. So I think you can do it if you have stagnant in some parts of practice this, you can go back to video, watch the video, and then go back to practices. So I'm waiting you in next lecture.